As we have discussed census and sampling. What is census? Census is nothing but studying each and every unit of the population is called census. So census always gives you accurate and correct results, but whenever the population is very high or infinite, if the number of units in the population is too large, studying each and every unit consumes a lot of time and money. So whenever the complete analysis of each and every unit of the population is difficult, we go for another technique called sampling. Under sampling, we collect a small sample, a small subset of the population, and instead of studying each and every unit of the population, we only consider those selected units from the population, and we perform the respective study to draw the conclusions, which is called sampling. The advantages of this sampling are nothing but it reduces time and cost, even though we are only considering only subset of the population, it equally gives correct results as of census. So depending upon our study, in some cases we go for census, in some cases we go for sampling. Now let us see what are the basic terms involved in our sampling. So you refer here Rahul book page number 87 for this. So let us see what are the basic terms in this sampling. So we have sampling. Just now we have discussed what is sampling. Next one is nothing but population. Population is nothing but, generally population we refer as nothing but the collection of individuals. But in statistics, population means that may be a collection of animates or inanimates. Population means it is a collection. That collection may be animates or inanimates. What I mean by animates? Animates are nothing but living things like human beings or animals or anything. Inanimates means that those may be non-living things also. Means population here not only means a collection of animates, depending upon study, it may be a collection of non-living things like the number of cars produced by manufacturing units or the number of pens produced by a manufacturing unit. So population is nothing but collection of animates or inanimates. This population size is nothing but, next term which we define is nothing but population size. Population size is nothing but the number of units in the particular population is called its size. And we have two types of population called finite population and infinite population. Okay, what do I mean by finite population? Finite population is nothing but whenever the size of the population is countable. So if I take the number of workers in a company, okay, if my objective is to study the income, different income levels in a particular company, then the population there is nothing but the number of workers in that company becomes population there. I think what is the size of the population there? It is always countable depending upon the size of the company. It may be 10, 100, whatever it may be. Always it's a limited number or counted number. So whenever the number of units in the population, or if the population size is countable, we call that population as finite population. So the best examples we can take are nothing but number of electric fans produced by a company per day or per month becomes the finite population. Number of stars in the sky becomes infinite population. It's negative, meaning whenever the number of units in the population is uncountable, we call that as infinite population. So if the number of stars in the sky is uncountable, similarly the other examples you can take are nothing but water in the ocean is uncountable. So these comes under finite and infinite population. So what is sample? Sample is nothing but these are the different terms which we use while dealing sampling. So we are first discussing all the terms which we are going to use in sampling techniques. So sample is nothing but a subset of population. Okay, A subset of population means we are selecting in general, you know what do you mean by sample? When you go to any shop or anything to buy any particular commodity, you are going to consider a small set of the commodity which is called sample. In the same way, subset of a population is called sample. Its size is nothing but number of units in the sample is called sample size. What is sampling unit? Sampling unit is nothing but the constituents of the population which are individuals to be sampled from the population is called the sampling unit. So what is sampling frame? This is very much important. Sampling frame. So I'll give you an example. Let us say that we have population size as 1000. So I'll take an example for better understanding. Let us say that a company produces 1000 fans per month. Okay. Now you are given with data that production of fans in different months is given to you. Okay. Now your objective is nothing but to test. Your objective is nothing but to test the quality of the fans produced by the company. So to test the quality of these fans produced by the company, what is the population there? Population is nothing but 1000 fans produced in any month, say January. Now to study the quality of those fans produced by the company, instead of studying the lifetime of each and every fan, what you are going to do is you are going to select a small sample, means out of 1000 units, let us say that you have selected only 10 fans from that, and you are going to check the you are going to do the quality check. What is sampling frame means? All these 1000 units, okay, sampling frame is nothing but population consists of 1000. All these 1000 units are given some labels or and names, means you are arranging all the population in a frame. Okay, from those frame you are going to select the required 10 units, means for proper selection or for easy selection of sample from the population, we are going to arrange the entire population in a frame which is called the sampling frame. From that sampling frame, you are going to choose the required sampling size. Okay, the next term is nothing but parameters. What do you mean by parameters? Means these are nothing but the constant. We have two different sets called population is one set. A sample is nothing but a subset of the population. We are terming that as sample. So parameters are nothing but the constants. Most probably the statistical constants of population are called parameters. The statistical constants of sample are called statistics. Okay, the statistical constants. What do you mean by statistical constants? Well known mean, median, mode, standard deviation, all these you know a little bit. Mean, median, mode, correlation, regression, all those are nothing but statistical constants. The statistical constants of population are called as parameters. The statistical constants of sample are termed as statistics. Now, these are the different terms which we use in sampling. The next topic which we are going to deal is nothing but types of sampling. Types of sampling. So we have basically we have two types of sampling which are nothing but random samplings and non-random sampling techniques. Non-random sampling techniques. These are the two different techniques we have. So under this random sampling technique, again we have further division called stratified, simple random sampling, stratified random sampling, systematic sampling and multi-stage sampling. So these are the sampling techniques under random sampling. Under non-random sampling we have under this we have judgment sampling, okay, quota sampling, convenience sampling. So we have different types of sampling techniques. First of all, broadly they are classified into two major types called random sampling techniques and non-random sampling techniques. These random sampling techniques also called as probability sampling techniques. Second one is nothing but non-random, non-probability sampling techniques. Again, these random sampling techniques are divided into simple random sampling, stratified random sampling and systematic sampling. Those non-random are classified into judgment, quota and convenience sampling. Let us discuss all these one by one. What do you mean by random sampling techniques? So what do you mean by sampling? Sampling is nothing but collecting a small subset from the population is called sampling. So while selecting the sample, means out of 1000 fans in the earlier example, out of 1000 fans you are going to select only 10 fans. So which 10 are to be selected? Okay, you have 1 to 1000 fans there, which is this stands for population size. So because of time and cost we are going for sampling. What is the sample size? You are going to select 10 units. So which 10 are to be selected for as sample? So which 10 are to be selected as sample is the question mark here. So for that selection we have two types called random and non-random sampling. Let us discuss this first so that you can go for the second one. Non-random sampling techniques means, what do you mean by random in general? Random means if I say that any two girls randomly from your class means any two, that may be you or any girl from the third bench. There is no particular rule in selecting if I use the word random. So non-random techniques means out of 1000 units we are not picking the units randomly. There is some rule. Let us say judgment sampling, under judgment sampling. So always, as I said you that we are using two words called investigator and respondent. Here the one who collects the data is called again investigator or judge. Okay, under judgment sampling, okay, one of the non-random sampling techniques, if the opinion of judge is concerned, means we use that as judgment sampling. I'll give you an example. So the objective of the survey is there. What is the objective of the survey? Is nothing but to study the average income levels of population in a metropolitan city. Any city, say, let us say X. What is the objective of this study? To study the income levels of people in any metropolitan city X. So now if we are using the judgment sampling, then the selection of those units, which families or which categories are to be involved, is mainly depends upon the opinion of the judge or the investigator, the one who collects the data or the one who organizes the survey is going to play a main role in collecting the sample. So here we are not assigning. So if we want to know the average incomes of people in a metropolitan city, like if it is a metropolitan city or any city, we observe that generally three categories of families or people in the society: below poverty line, above poverty line and middle class people. If the investigator or the judge is not willing to visit the low income people, and if you want to visit only the below poverty line or higher income families in the city, then he is going to collect the data only from that particular sector of the society or the city. Then if we draw the conclusions depending upon this sample, he draws the conclusion that the average income levels in that city are good or above the average. Means under non-random sampling, the first one under judgment sampling, the selection of units in the sample mainly depends or is partial to the opinion of the judge or the investigator or the one who performs the survey. So even though it's a easy method of collecting the sample, the results may be misleading if the judge is not well experienced. If the judge is not well trained or he is not good at work, then there is a chance that the results of the survey may be misleading. Next one is nothing but quota sampling. Under quota sampling, okay, this is also another non-random sampling techniques only. Non-random means we are not assigning any rule for selecting the sample into the sample. Under quota sampling, this is also one of the judgment sampling only. Those units are selected into the sample where certain quotas are assigned to the units in the population depending upon the religion or political or some other individuals. Means this is more similar to judgment only, but if we are performing any survey related to the religious activities, then the data from those religious people only collected, means this is also one of the judgment sampling only. But under this, the units in the population are given some quotas depending upon the previous defined domains like religious factors or social factors or political factors. So these are the some of the non-random sampling techniques. So even though these are easy methods of collecting data, there is no scientific approach in collecting data. These are mainly non-random. They don't have any scientific rule or law of selecting units into the sample. If these are implemented, if the judge or the investigator is not well trained, then the results of the survey are misleading and doesn't fulfill the task. So these are very rarely used. The second category of sampling techniques is nothing but random sampling techniques. Under these random sampling techniques, we have simple random sampling, stratified random sampling, and systematic, and one more called multi-stage also. So what is simple random sampling? Simple random sampling is nothing but, name itself tells that these are random techniques. Random means and other name for these are nothing but probability. Probability is nothing but chance. You know, this probability means chance. Whenever we have uncertainty in the phenomena, we use the word called chance. Now, what is simple random sampling? Simple random sampling is nothing but, the first point you should remember is nothing but, this is used when the population given to you is homogeneous. What do you mean by homogeneous? Let us say that, let us take a simple example. Now you are with the task that you want to know that average passed out percentage of students from Shantiniketan College. The objective is nothing but, you want to know that what is the average pass percentage of students during the academic year 2019 and 2020. Then what is the population there? Entire students in the college becomes the population there. Let us say that our college has 1500 plus strength. Let us say that. If that is the strength, okay, what is the objective there? You want to know that what is the average pass percentage of the students during the particular academic year. Then it's the time is limited there. Then it's very difficult to take the results of each and every student in the college. Then what you are going to do? You are going to select a few randomly, not any particular rule, randomly. Okay, randomly you are going to chase 50 to 100 students, and you are going to note the results of that, and you are going from that, out of 50 students, you are going to calculate the number of failures and number of passed out candidates. If it is 30% or 40%, you are going to draw the conclusion that from this college we observe that 30% of the students pass or fail every year. So while selecting the students from the college, okay, Shantiniketan, we are not assigning any rule there randomly. Okay, randomly from this randomly he is going to each and every class, he is going to pick one student, he is going to record the data, means randomly, there is no any particular rule there. So where such technique is called simple random sampling techniques. This is used, or this gives best results when the population is homogeneous. Oh, okay, let us go to stratified. What do you mean by stratas? Stratas are nothing but division into layers. What I said? What I said that division of layers. Stratas are nothing but division of layers. Division into layers. Now the same, let us take the same example. We have Shantiniketan Women's College, where we have from intermediate, degree, PG, and we have subgroups in each branch also. Now if the objective is to know that how many PG students are, or how many intermediate students are clearing their examination every year. What is the objective here? What is our objective here? Our objective is to study how many intermediate students are clearing their exam every year. What is the objective in our previous case? How many students are clearing, what is the pass percentage of the students in our college. So here in the second case, for the first one, we can treat the entire population, entire students in the college as homogeneous. Here, what is the question here? How many intermediate students are clearing their examination every year? For that, we cannot consider entire population, that is entire Shantiniketan college as our population. If you consider that, if I go for same simple random sampling, if I pick up 5 students from first floor and 5 students from second floor, 5 students from third floor, there is a chance that I'll get some of the PG students, I'll get some of the BCom students, some of the intermediate students. Means my objective is only to study the average passed outs from intermediate. But if you take the entire Shantiniketan Women's College population, then if I pick up randomly few students from each floor, the sample may consist of all the combinations or all PG, degree, inter, which is not required for my study. Means whenever with respect to our study, if the population is considered as heterogeneous, so if I consider only intermediate, my aim is to study the results of intermediate, I cannot consider entire Shantiniketan as my population. Then what you need to do? You need to divide entire college into different layers or different stratas, like this is PG, this is UG, these are intermediate. Again under intermediate you have intermediate first year and intermediate second year. Then you should select students only from these last 2 divisions which stands for inter. So with respect to study, whenever our population resembles heterogeneous, then what you need to do? You need to divide that into homogeneous layers which are called stratas. Then we can go for again SRS only. Basically this is the one which we use. But whenever the population is heterogeneous with respect to our study, we cannot directly use we cannot directly use simple random sampling. Then what you need to do is you need to divide entire population into stratas, which are the layers which are called stratas. Then you should go for simple random sampling, whatever we have done there. So SRS is used when the population is homogeneous. Stratified random sampling is used when it is heterogeneous. What do you do when it is heterogeneous? You should divide that into layers or the stratas or subgroups. Then you should go to simple random sampling again. Next one which we have is nothing but systematic random sampling. What is systematic random sampling? So whenever, let us take only this best example you can understand. So if you are performing a household survey, Okay, household survey, some socio-economic survey related to a number of households in a colony. I think what is the population there? Entire houses or the families in that colony becomes the population there. So if it is a colony or a city, let us take colony only. I think all the households are attached with a house number. They are identified with a house number. Moreover, all those house numbers are systematically or sequentially arranged there. 1-1, 1-2, 1-3 up to 1-100 means when do we use these three techniques means when do you use this systematic means whenever the units in the population are sequentially or systematically arranged, then we can go for systematic unit. Let us say that we have a colony of 100 families where the first row or the first street consists of 10 houses, second street consists of 10 and so on. Now I think all those are serially arranged. Then I can pick up randomly 2 units from the first street, 2 units from the second, 3 units like that. Means when do you go for systematic sampling means whenever the units in the population are systematically or the sequentially arranged to collect a sample from such a population, we use systematic sampling. So these are the topics which we have discussed, basic terms of sampling and types of sampling. In the next video, let us discuss about the measurement of scaling techniques. Okay, thank you.